All right, guys, we are going to do your notes on chain rule via video. So you are either watching this the day that you are finishing your CIA, or maybe you're watching it for homework. But either way, you learned product and quotient rule last class. Today, chain rule is basically the third derivative rule that you need to know. So on your pink sheet, okay, we have already recorded chain rule right here. Okay, but let me just teach you how to use it with your notes for today. Okay, so the chain rule is going to be used to take the derivative for compositions of functions. So if you have a function f of g of x. Okay, so essentially you have g is inside f. Okay, you would take the derivative of f first. You're going to keep your g of x function exactly the same. But then you're going to multiply by the derivative of g, which would be g prime. So essentially think of it kind of like layers. You take the derivative of f first, it goes to f prime. Then you take the derivative of g second. So for some rules here, your derivative of sine, snow cone. Okay, the derivative of sine is cosine. But the derivative of sine u would be cosine u times u prime, where you take the derivative of sine first, turn it into a cosine. Remember what I said, that middle part is going to stay exactly the same, but then you're going to multiply its derivative behind it. Okay, let me show you what I mean by that. Then we'll do a cosine example. Take a look at number 1. The derivative of sine 2x plus 1. So this 2x plus 1 is inside the sine function. So you're going to take the derivative of sine, that would go to cosine. 2x plus 3 stays the same. But then you're going to multiply the derivative of 2x plus 3 behind it. So the derivative of 2x plus 3 would be times 2. So that would be your u prime. So you keep your cosine of u exactly the same middle part that it was, times the 2 behind it. So my dy dx, I'm going to rewrite this here, would be cosine 2x plus 3 times 2, or 2 cosine 2x plus 3. Okay, then you'll notice that right below that, you're asked to take the second derivative. So we would say, okay, well, if this is 2 cosine, let's look at our snow cone here. Cosine, my derivative goes to negative sine. So it'd be negative 2 sine. Remember, the 2x plus 3 stays exactly the same for now, but then I times its derivative behind it. So the derivative of 2x plus 3 would be an extra times 2. Okay, then from there, we're going to rewrite it. D squared y dx squared, remember that just means second derivative, would be 2 times a negative 2 in the front is negative 4 sine 2x plus 3. Okay, then we're asked to take the derivative one more time. So I would say, okay, well, if I'm at negative sine, that's here in my snow cone. Then if I take the derivative, I'd be at negative cosine. Remember that your 2x plus 3 initially stays the same, but then I have to multiply that derivative behind. So 2x plus 3, again, the derivative is still an extra times 2. So I end up essentially with a negative 8 cosine 2x plus 3. Okay, and that would be for d cubed y dx cubed. Okay. Take a look at the one right next to it. This time, my outside layer is cosine, and my middle is a 6x squared minus 4x. So I would look at my cosine. The derivative of cosine goes to negative sine. Keep your middle part exactly the same. So your u That's what we're calling that middle function. K stays exactly the same and you multiply its derivative behind it. So think for a minute about the derivative of 6x squared minus 4x. 2 times 6 is a 12x, and then minus 4. Okay, that would be your u prime. Okay. So let's fill in this gap up here at the top. We said the derivative of cosine goes to negative sine x. Well, then if it's cosine of u, it would be negative sine u prime. Where basically you're just taking whatever that middle is and multiplying its derivative at the end. Okay, when you're ready, go ahead and turn the page, please. Okay, so taking a look at the back, we now have our e to the x. So remember that the derivative of e to the x is e to the x again. But what if it's not just an x? What if your exponent is u, where u is essentially x stuff, but it's not like just an x by itself? Then your derivative would be e to the u times u prime. Okay, so let's take a look at number 4. My function is e to the 10x plus 5. Then the derivative of e to the 10x plus 5 is e to the 10x plus 5 again. But then I have to multiply by the derivative of what that u is, where u is your inside function. And the derivative of 10x plus 5 would be an extra 10. So dy dx equals 10e to the 10x plus 5. Okay. So initially you'd usually write your u prime at the back, but then I'll usually rewrite it to put it in the front. Okay, here's why. I'm taking now the second derivative. So I would say, okay, well, the derivative of 10e to the 10x plus 5 is going to be exactly the same as what it was. 10e to the 10x plus 5 again. But then I have to multiply by the derivative of the inside function. So if it was a 10x plus 5, that'd be an extra times. And then we know that 10 times 10 on the outside means that my second derivative now is 100e to the 10x plus 5. Okay, but think about that middle layer. The 10x plus 5 up here is not changing. Its derivative is being multiplied at the end. Okay, let's take a look at number 5. We have e to the 3 sine x. So the derivative of e to the 3 sine x is e to the 3 sine x again, times. And then I'm going to take that inside function, we're calling it u, and we're going to multiply its derivative at the back. So the derivative of sine would go to 3 cosine x. Okay. Take a look at one more. Look at number 6. E to the 3x to the 5th minus 10x. The derivative of that would be e to the 3x5 minus 10x, and then times, and then you're going to take whatever your inside function is. Okay, in this case, your inside function is what that exponent is, and you're going to multiply its derivative at the back. So 5 times 3 would be 15x4 minus, and then 10x would be 10x to the 1. So you do 1 times negative 10, it's negative 10. X would drop off to go to the 0. Okay. Now, remember what we talked about when we learned product rule, that anytime that you have multiple terms, you really need to group those. So my rewrite on this would be dy dx equals 15x4 minus 10 times e to the 3x5 minus 10. Okay, but keep in mind, okay, that these are the same. It's really just the way that you'd be expected to see an answer choice on the AP test. Okay, let's come down to the next one. For power rule, if I have a power x to the n, remember that I do the n down to the front, and then I reduce the power by 1. So my n goes to the front, and then I take away 1 from the power. Well, now let's say that your base isn't just an x, it's a u. where u is x stuff, but it's not just an x. Then my n still times is down to the front. My u is still to the n minus 1, but then I have to multiply my u prime to the back. So let's take a look at number 8. Okay, remember, u is like the middle of the equation. So in this case, my u is a 2x plus 7, and I want to take the derivative. Well, then my 4 comes down to the front. My 2x plus 7 stays the same, but now it's to the third. So notice it's almost like you're taking the derivative around that core. So my 4 comes down, I take away 1, but then I have to multiply by the derivative of what that core is. So if it's a 2x plus 7, that would be an extra times 2. Okay, then don't forget that if I have a 4 times in the front and a 2 times in the back, we can combine that to be dy dx equals 4 times 2 would be 8 times 2x plus 7. Okay, let's say we wanted to take the second derivative of that. Okay, you're going to take the derivative around that core. So my 3 times 8, that's going to give me 3 times 8 is 24. My core stays the same. I reduce the power by 1, so it's going to go from a cubed down to a squared. But then because this isn't just an x, it's a 2x plus 7, I have to multiply its derivative at the end. 2x plus 7, the derivative is still 2, which means that my second derivative, d squared y dx squared, is equal to 24 and 2. When I multiply those together, it's going to be 48 times 2x plus 7 squared. Okay, last one like that. We're doing now the third derivative. So my 2 times is down on the 48. 2 times 48 is 96. My 2x plus 7 stays exactly the same, but then I'm going to power it down from a squared to a first power, and then multiply the derivative to the back. So if this is a 2x plus 7 is my 4, I get an extra times 2, which means that this is going to be 192 times 2x plus 7 to the 1. Okay. So when you're doing chain rule, you're just working around what that core is, but you're keeping the core the same and multiplying its derivative at the back. So let's say now we're doing number 9. Okay, my middle function is my 6x squared plus 3. I'm going to take the derivative around it. So my 5 will come down to the front. My 6x squared plus 3 is going to be to the 4th power now times. And then I have to take what this center core is, multiply its derivative at the back. So if it was a 6x squared plus 3, my derivative would be a 12x. Remember that your plus 3 is going to fall off because it's a constant by itself. Okay, then remember a times 5 in the front and a 12x in the back, that's going to combine to be a 60x times 6x squared plus 3 to the 4. For your, I'm just going to call it y prime. Okay, but we know that y prime and dy dx, same thing. Now, let's say this is my y prime, and I want to find the second derivative. Okay, look at this equation, and I want you to think about what rule would you need to take the derivative of 60x times 6x squared plus 3 to the 4th. Okay, hopefully you remember that whenever you have x stuff times more x stuff, you're going to need to use the product rule if you want to take the derivative of that again. So let's review how to do that. My u would be a 60x. My v would be a 6x squared plus 3 to the 4th power. Okay, then we're going to take the derivative of both of those parts separately, then write our cross product. So 60x, the derivative is just a 60. For v prime, I'm gonna take the derivative around the core. So my 4 is gonna come down to the front. My 6x squared plus 3 is now to the third. But then I have to times by the derivative of that core at the back. So 6x squared plus 3, my derivative in the middle is still a 12x. So here's my cross product. I'm gonna have this plus this. So let's write it. D squared, or actually, let's just put y double prime, just because it's easier. We know it's the same as the second derivative. Okay, I'm gonna have 60x times 4 times 12 x times 6x squared plus 3. That's this diagonal. Okay, and notice that I put the 4 and the 12x kind of in the front because all of this crap is going to go together in a minute. Okay, then plus, then this diagonal would be 60 times 6x squared plus 3 to the 4. Okay, then all that I would want you to do is times these pieces together. So I want 60x times 4 times 12. Please don't judge me, but let's just calculator that out. So we're doing 60 times 4 times 12. Okay, that gives us 2,880. 2,880. Now, x times x will be an x squared times a 6x squared plus 3 plus a 66x squared plus 3. Okay, that would be your. Okay. But notice the only reason that I had to do product rule here is that it wasn't just a number in the front, it was a number with an x. So if it's x stuff times x stuff, that's where you would need product rule. Okay, go ahead and turn the page when you're ready. 3 examples left. Okay, take a look at number 17. Number 17 is y equals cosine cubed 4x minus 8. Okay, I want you to rewrite that. Remember that if they put the cosine cubed here, that means that your entire cosine of 4x minus 8, the whole thing is cubed. Okay, if they put the little 3 power on the inside, that means all of it is cubed. So I want you to just take a moment to identify how many layers this one has. Instead of just having 2, it actually has 3. Your outside layer is the cubed or the power. Okay, then what's cubed is a cosine function. And then inside the cosine function, you have a 4x minus 8. So we're gonna have to just go layer by layer. Let's start with the power. Remember, I take the derivative around this core. So dy dx equals. My 3 comes down to the front. My cosine 4x minus 8 stays the same, but then I'm gonna reduce its power. So instead of being cubed, now it's gonna be squared times. Then I'm gonna take the middle of this equation and I'm gonna put its derivative behind that. So if it's a cosine 4x minus 8, snow cone, snow cone. If I'm at cosine, the derivative of that goes to negative sign. And I keep the 4x minus 8 the same. But then I'm gonna take that function in the middle. The 4x minus 8 is the next layer. I'm gonna times its derivative at the back. So 4x minus 8 gives me an extra times 4. Okay, then from there, when you're doing this delta math, which you're gonna have like all the way into next week to do, okay, it's gonna be 3 times 4 is 12. Also times the negative is a negative 12. So for your answer on delta math, you would put negative 12. Then I would put probably the sine 4x minus 8 next. And then the cosine squared 4x minus 8. Okay. But remember that technically this is still right. It's just not like simplified all the way. Okay, let's take a look at number 18. This time your sine to the 4 is on the bottom. Remember that we can rewrite x's off the
Good
bottom.
morning, Eagle. Today is Monday, October 7th. I'm
Dang it.
Rebecca. And I'm Luck. And you're listening to Eagle Ear. Please.
Okay. So number 18, sorry, I had to pause. I didn't want to have y'all trying to like hear me over the announcements. So my sign on the bottom is to the 4th. That is the same as the entire sign 5x plus 1 to be to the -4. Now I want you to think about why. Okay, the 4th is written into the problem, right? But then the negative comes from the fact that that power is on the bottom. So let's do it just the same way we did last time. dy dx equals. We're gonna take the derivative around this core, but let's count the layers. You have a power on the outside. Inside the 4th power is sine. And then inside sine is the 5x plus 1. Okay, so let's go one layer at a time. -4 is gonna come down to the front. My sine 5x plus 1 stays the same. But my new power is a -5, because remember, I'm taking away 1 from an already negative number. Okay, then my sine, the derivative goes to a cosine 5x plus 1. And then my 5x plus 1 gives me an extra times 5. So for my final answer, I could go ahead and combine the -4 and the 5. That'd give me a -20. Cosine 5x plus 1. But notice I'm going to drop this term back into the bottom. That's really a sine to the 5th. 5x plus 1. Okay. All right, last one. We have a dy dx for y equals e to the sine 2x minus 5. Let's count our layers. Our outside layer is e. Okay, then inside e is sine. Then inside sine is 2x minus 5. Remember, we start with the outside first. The derivative of e is going to be e again to the sine 2x minus 5 times. Then I'm going to take my sine 2x minus 5. I'm going to multiply its derivative at the back. The derivative of sine goes to cosine 2x minus 5. Remember that my core stays the same, but then I multiply its derivative at the back. 2x minus 5, the derivative is a times 2. So for my dy dx here, it would be 2 cosine 2x minus 5 times e to the sine 2x minus 5. Okay. So just kind of look at that, see if you have any questions. Okay, we are completing the CIA on Wednesday. Your homework for for chain rule is going to be opened starting today on Monday. However, you'll have all the way through next Friday to finish it. So please don't sweat about this. If you need help with it, we're going to work on this some more in class next week once we're finished with the CIA. Okay? Y'all have a wonderful day and I'll see you Wednesday. Unless it's Wednesday and then I'm already seeing you right now.